In this video, I'll show you how to find the area of a polar region. The question reads, find the area of the polar region that's bounded by r is equal to 1 plus cosine theta and lies within the bounds 0 and pi over 6. To find the area of this region, we'll need to use the formula right here where the area is equal to the integral between a and b for the integrand half times r squared with respect to theta. Let's go ahead and set this up. We have the area is equal to the integral between 0 and pi over 6 for the integrand half times 1 plus cosine theta squared d theta. The first thing that I'll do is pull out this half. I don't need to integrate that. I have 1 over 2 times the integral between 0 and pi over 6, and at the same time I'm going to expand that. The binomial 1 plus cosine theta can be changed into 1 plus cosine theta, I'm expanding here, plus cosine theta plus cosine squared theta. These two terms become 2 times cosine theta. So I'll replace this expression into here. This term and this term are easy to integrate. In fact, I'll integrate them first. I have 1 over 2. I'll introduce square brackets where I have the integral of 1 is theta, and I'll find out what that is equal to when I evaluate it at pi over 6 and 0. The integral of 2 cosine is also easy to integrate. I'll write down plus the integral of 2 cosine is 2 times sine theta, and I'll also evaluate that at pi over 6 and 0. But this term, on the other hand, is the more complicated one. In fact, in order to integrate cosine squared theta, we need to use one of its identities. An identity for cosine squared theta is a half angle identity and looks like this. We have 1 over 2 bracket 1 plus cosine 2 theta. So we'll need to integrate this expression as opposed to cosine squared theta. Let me go ahead and do that underneath. Let's find the integral for 1 over 2 bracket 1 plus cosine 2 theta. First thing that I'll do is pull out this half. 1 over 2 times the integral of 1 plus cosine 2 theta d theta. Next, I'll integrate this term and this term individually. The integral of 1 is theta. So 1 over 2 square bracket, this part becomes theta plus the integral of cosine 2 theta d theta. To integrate this, we'll use u substitution. So I'll set u is equal to 2 theta, this part, and I'll derive this implicitly, where I have du is equal to 2 d theta. Solving for d theta, I end up with du over 2 is equal to d theta. I'll take this and place it right here. So I have the integral of cosine u du over 2. Pulling out this 1 over 2 because it's a constant. 1 over 2 times the integral of cosine u. And I know the integral of cosine u. It's sine. So I have 1 over 2 times sine u, which we know is 2 theta. And normally we would write down plus c, but we won't in this case because it is a definite integral and it is being integrated between 0 and pi over 6. I'll take this now and place it where we left off. This is how your equation should look like up until this point. Now what we have to do is evaluate each of these terms between 0 and pi over 6. This requires a lot of calculations. So let's start with this part. Remember, we have half on the outside. And for that first part, we have pi over 6. I'm evaluating this theta at pi over 6 minus 0. This part's done. Next part. We have 2 on the outside, sine pi over 6 minus sine at 0. That part's done. Now, for this last part, I have half on the outside, and for this, I have pi over 6 plus 1 over 2 sine 2 times pi over 6 minus 0 plus half sine at 0. Using my calculator, I'll start over here, and whatever I get within this bracket, I'll multiply by half. So I have pi over 6 minus 0 is the same thing, plus 2 times sine pi over 6. Make sure that your calculator's in radians. Mine is. Minus sine 0, which is also 0, but I'll place it in here. So I just found the first two terms. Now I have to do this one. Plus 1 over 2 times pi over 6. And make sure that every fraction is placed in brackets. So I place this in brackets, plus 0.5 times sine of pi over 3, because this becomes pi over 3, minus all of this content now. We have 0 plus half sine 0. That's all equal to 0. I'm going to close the brackets here, and I end up with 2. I'll multiply that by half, which gives me 1. Therefore, my area, bounded between 0 and pi over 6, is approximately equal to 1. And there you have it. That is how to find the area of a polar region.